Welcome viewers to part 2 of FPV drone building. Now in this video I'll just be showing you the parts required when building a drone, and those parts usually come as a kit. But if you're going to buy a drone and build it in parts, I'll show you sometimes it might be cheaper to get parts individually, and you need to know what actually works with what. Now a frame, on the other hand, you need to understand what size your frame is, and this frame is built for 5-inch. So this blade right here uses a 5-inch this motor right here uses a 5-inch blade, and generally gives you enough space away from the body of the drone. Now as you can clearly see that it looks like it's built up together. The whole drone was built up together, but I just tore it back apart because I decided to make a video on this drone instead of getting a new drone out of the box, and I don't have much time to make the videos. Now it doesn't make much of a difference. All you need to do is understand that you need a soldering station. You don't need any hot air, any rework station, just soldering. You need to understand how to solder. And now I will not be showing this in this series, and by the time you're able to solder, everything will work good. So here is the array of my drone, and you can see those here are antennas, and those antennas, this is the connector that goes to the transmitter. Now transmitter, also called the TX, where is it? So prior to going to that, I'll just finish with that. So this little board that you see here, this little board is the electric motor control. So it's just control, it's like basically the EMC. So it just controls the engines, also known as motors, and this wire can disconnect, but that's just a specific model, and everything can vary depending on the model. Now first and foremost, with your EMC here, you need to connect your motors, as in, if you look at, there's 3 wires and those wires are flat. They go in a pattern, as in there's no different color codes, but just one wire to the far right, one in the center, and one to the left, and they're all flat. The wires is furthest to the left or furthest to the right, let's go with that. The wires is furthest to the right of the motor when you look at it at any direction. When you put the IMU in place, that wire goes furthest to the right also. So you're just going to solder these wires exactly how they are placed, and I can't move this right here, but I can tell you this first pin here, if I get someone to point it out. So this first pin here goes to the furthest right wire, this one goes to the center, this one goes to the furthest left. As for this one, this wire here is the furthest left because it's all the way on my left hand, and this is my left hand, just as a reference. So this wire goes on the furthest left here, the first left pin. This one goes in the center, and this one goes to the right. So the one that's on the furthest right, which is the one that's on my right, actually, it goes to the furthest right. So the wires just go in a simple pattern like that, and once you do it like that, you're good to go. There's no way you can go wrong by the time this is connected. And this is generally the same way for every single FPV drone. Here is my power connector, my battery connector, and I have a capacitor that came with the kit. So what a capacitor does, it generally stores electricity. For example, if the battery is dying out, it still has electricity in it that prevents it from abruptly shutting down. And also, whatever happens, if the battery just disconnect or whatever, it will slowly reduce the charge instead of just cutting off the powers immediately. Cut off the powers immediately, there are transistors on the motherboard of the flight controller that can damage. Now that's it for the EMC, the motor control, and those are the motors. Everything does not come built in. You have to generally solder it on, or also screw whatever that can actually screw on. So that's generally it. It's quite easy, it's quite comprehensible and easy to understand, but I'm going to go to the more difficult one. but that's not yet. Here is my VTX, and your VTX, if you cannot find out the labels on it because it's probably a used VTX, so this one is actually new. But if you have a used VTX and you can't see the label, always try to find out. Use Google Lens and look for that VTX. Try to get the features around it. Try to get exactly what labels goes by the pinout. The pinout is very important. So this one has video, ground, 5 volts out, trump, ground, and also 7 volts to 46 volts maximum in. Now 5 volt out and the ground and also video, there's 2 grounds, so video, ground, and 5 volt out, they all go to the camera, and they use a long cable that has 3 pins for, that has the 5 pin going in here, and they also break into 2. One 3 pin goes to the straight to the camera, which is that it goes inside of here, and the remaining 2 is not pins. There's 3 more. The remaining 3 is not pins, but it's actually just wires that have to just solder onto the board. Some drones use pins, so you might be lucky if you do not have any soldering to do. So how does it work? So you have your VTX here, which is usually to the rear of your drone, and this is the antenna. The antenna can disconnect, and I have a tie strap on it because it ties straps to the frame. I'm just gonna leave it there. So this antenna can disconnect, but have it connected, and this is your camera all the way to the front of your FPV drone. And what goes in the center? This goes in the center above your EMC. Your EMC is your electronic motor controller. Now on the screen here, I'll tell you what exactly is going on. So if you look at on the screen, and you can see, I'll start with the VTX, which is that. If you look at on the screen, you will see your VTX. You can always align your board to your pinout diagram. Align your board the same way it is on the screen or on the paper if you have a paper. So you can see at the top here, that red wire that I have on here, you probably might not see the color, I'm not sure, but if you can see the color, that red wire at the top here, just as illustrated on the pinout, that red wire is your 7 volts to 76 volts maximum input. It's generally labeled as VTX positive. That means that's the power to the VTX. Now if you do not have that pinout working, that VTX positive working, you need at least 7 volts to 46 volts for your specific VTX. Mind you that some VTX use less, some VTX use 9 volts, and if you do not have more than 5 volts coming out on your board, more than what the required voltage is for your VTX, therefore what you need to do is run that wire directly to the battery. So that red wire for my VTX positive, you can go directly to the battery. The battery is usually 22 volts for this Hollywood drone, but then again, since I have this working, and this will basically be a direct bridge to the battery. That VTX Plus is usually a direct bridge to the battery, or sometimes on 9 volts, therefore I can connect it there. But if it does not have that pin here, for whatever reason, is it damaged because of poor soldering and removal of solder, you just send it directly to the battery. That yellow wire is connected to V0, and that yellow wire comes from the VTX. Now I'm only explaining the VTX wire right here. This is the VTX wire, and like I said, that VTX positive goes directly to the where you see the input for the voltage of the VTX. That yellow wire could go directly to the camera, but I have 2 wires cut out. I have a positive and a negative. It's a basic 5 volts and a basic ground. The reason why I have it cut out, I cut it out from the VTX video. I cut out from the VTX ground and 5 volts out. So on here I have video, ground, 5 volt out. Those are my first 3. Those 3 were connected together in a in a cable with a connector at the end, I cut out that connector with excess so I can connect that to my VTX, and I cut that halfway so it can connect to the flight controller, and the remaining goes to the board. So this is what I actually cut out: the 5 volts positive, which is the red, the ground, and the video, which is what's on here. So I cut it out just enough length to go to the camera, and the video goes on the V0 as seen on the board right here. So we have now gone through the VTX positive, what it is, and the video or V0. The other things you have to get to understand is GND on the board means ground. So ground is usually black, and you can also trace it from your connector by counting the pins, and while counting the pins, counting each label for the pin out. And that's the same way you do it with any other thing that connects with a connector. That white wire is a receiving wire. So what it does, it receives information from the flight controller and it sends it to the VTX. Now that's the jump wire right there. That jump wire is basically a receiver on here. So since it's a receiver on the VTX, or it can work as, with a good understanding, the same way you also have your transmitter here that sends your data to your controller, also known as your receiver. Wherever you see T on a micropart like this, like the receiver, sorry, the transmitter, T on that transmitter will connect to an R on the flight controller. Wherever you see R on a transmitter, it will connect on the T. So it's a receiving end and a transmitting end. So that jump wire connects to the T on the receiving end. So it receives the information and the flight controller transmits the information. So that's the VTX right here. So we have now gone through the camera wire, why it's connected like that. And the camera wire here is dedicated for that. So you have a CAM here, but you can leave it blank. But we have VI right here, so that's video 1. And we have 5 volts and we have ground. 5 volts is self-explanatory. 5 volts is your red wire. Your black wire is always ground. And your yellow wire always has to do with video when it comes to your camera and also your VTX. So V1 goes to the camera. There's another wire actually connects to that, but it's not really needed for that right here. The last thing that we have to connect onto that is your receiver. And the receiver here, I'll put a little diagram of it. So we have R, one wire is called R, one wire is labeled T, another wire is labeled U, another wire is labeled G. Sorry, not U, it's V. That wire which is labeled R is the receiving end. That receiving wire will connect to a T on the flight controller. So this is the first wire right here, the yellow one. This yellow wire connects from here, which is R. It connects to T on the flight controller. So I have it on, I don't know if I can see from here because my screen is tilted, but I have it on T6. That T wire here, which is the transmitter, it transmits the data from that receiver here, and it will be connected to R6. Now, what you also need to understand, let me just finish this off first. So then we have V for voltage, which is 5 volts. So that red wire here from the receiver connects to the 5 volt output. You can connect to any 5 volt output. You can connect to also any ground. The black wire connects to ground. You can connect to any ground. So any 5 volt output from here can go on Well, I'll say any 5-volt input from your accessories can go on any 5-volt on your flight controller. So this need 5 volts. It can go on any 5 volts found on the board. And also this need a ground. You can go to any ground found on the board, no matter if it's not from one of the pinouts. It could be from on top of your USB port right here. This is a ground, definitely. Now those bypasses are what you're trying to avoid. Now on your motherboard you'll see stuff like, I'll just save the basics for now. On the motherboard you'll see your pinouts. You will see T4, and next to T4 you'll see R4 and this kind of stuff. T4 is the receiving wire that's going to be connected to that. So any receiving wire, so if I need to connect this here on T4, I could. Reason being, because right now it's connected on T6, but the UART in the ports of Betaflight flight configurator, in Betaflight there's a section called ports, and I'm going to be enabling port 6, UART 6 for this, because my receiver is connected to port 6, and automatically my other port for my my transmitter will automatically be enabled. So this does use S-bus, but it uses the Crossfire protocol, that's CRSF, and when flashing your drone, which we will get to soon enough, you need to also enable that protocol so you can actually work with this receiver. If you use a different protocol that's not compatible with this receiver, therefore you have to reflash with the proper firmware, because you'll not be able to get a receiver or receiver input. It's just going to be blurred out, because the system will recognize that you have a different receiver than the protocol that's installed in your firmware. Now, different issues with this drone, we can get to different issues later on in the series, but for now, if you have any questions, then please let me know. So this is your receiver. I've now explained the receiver. It's quite simple. Some receiver have more wires, but you can always just go to your drone flight controller's pinout, and you can also use the diagrams also, and it'll tell you where what goes. So it tells you every single thing. So for example, here I have my H7 drone here, and I can get a full overview. Not only from here, I can go to the wiring diagram, and here you can see for different types of receivers and different types of VTX. So those are my VTX down here. It tells you exactly how everything is connected, and those are my receiver up here. And there's more about receivers here. This is for my motors, how my motors will be connected, and this is for LED strip, which I do not have. This is for the camera. Everything is actually there. So luckily enough, I have a board that gives me all the information. It tells me how each receiver will be connected, if it's via S-bus or if it's via Crossfire. So generally, that's simply as that. It's quite easy. One thing I have to bear in mind is, for users that do not solder and they have a kit, just using this diagram right here, you can identify where what goes. So you have different connectors on the motherboard right here of your flight controller, and those connectors are for things like receivers can connect to one, and also VTX can also connect to one. So one can go here, one can go here. So you don't need to always solder. Some kits come with just connectors only, and that's generally it. It's as simple as that. But anyways, that's it for this video. If you have any questions, do leave a comment and I will respond to it as rapid as possible. In the next video, I will be going on to Betaflight and showing you how to configure your drone and get ready for flying.